All right. Hello and welcome, everyone. This is Diego Lopez moderating for MIT Horizon. Thank you all so much for coming today, and we are very lucky to have Michael O'Boyle here to discuss the opportunities and challenges of rapidly decarbonizing the US electricity system. We'll be doing a fireside chat format today, an interview style. So if you have any questions or would like any clarity on anything throughout, be sure to type it into the Q&A box below. Michael O'Boyle is the Director of Electricity Policy at Energy Innovation and leads the firm's Power Sector Transformation Program to uncover policy and technology solutions for clean, reliable, and affordable electricity in the US. Mike and the power sector team design and quantify the impacts of policies needed to decarbonize the US electricity grid, including clean electricity standards, wholesale market design, monopoly utility regulation, and energy efficiency policies. He's a frequent contributor to Forbes and has written for The Hill, The New York Times, and Green Tech Media. Before joining Energy Innovation, Michael received a JD from Arizona State University and a BA from Vanderbilt University. So thank you so much for joining us today, Mike, and we can just get right into it.
Thanks for having me, Diego, and thanks for that very nice introduction.
All right, excellent. So I guess I'd like to sort of start this interview today by talking about the key takeaways. So we've seen this 2035 report that is talking about or laying out how we can achieve like 90% decarbonization by 2035. And so in summary, what needs to happen by 2035 and how achievable really is this goal?
Yeah, so the 90%, well, for anyone who's not familiar with the 2035 report, it's a study that we did along with Grid Lab, which is an NGO focusing on providing technical assistance to advocates and regulators on renewable energy integration issues, and scientists from UC Berkeley and Lawrence Berkeley National Lab. And what we did was we used computer models to study the sort of economics pathways to reaching a 90% clean electricity system by 2035, which is really an ambitious goal. It's more ambitious than any other serious study that had been done to date. It was published last year. And really importantly, it aligned with a 1.5 degree rise in global temperatures, as well as a net zero pathway for the United States economy by mid-century. So um, your question was, what's it going to take? Well, it's going to take essentially rapid deployment of low cost but existing renewable energy and clean energy technologies. So from a practical standpoint, that means roughly doubling and almost tripling by the end of the decade the annual deployment or installation of wind and solar projects in the United States, and sustaining that rate of deployment throughout the decade. It's going to take new transmission. It's going to take utilities spending and purchasing a lot of these contracts. It's going to take some new grid operation strategies. Um, and we'll kind of dig into a lot of the details, I think, in this conversation. Um, but the findings of the study were really positive in terms of the benefits for the US economy, consumers, and public health. We found that the goal was achievable without increasing wholesale electricity costs. Um, we found that it created a net increase of about 500,000 new jobs through 2035. Grid dependability was maintained in the study, and like I said before, it didn't require any major technology breakthroughs. So, given the rate of innovation that we've seen in the last 15 years, I think it's reasonable to assume, our relatively conservative assumptions might be beat by the innovation of U.S. businesses and businesses around the world.
Very good to hear. That's very interesting. And so, with all of these goals in mind and this plan laid out, where do we currently stand policy wise? And what would be some of the most impactful policy changes we could make, soon or now to achieve this grid decarbonization in that time frame?
Yeah, that is the question, and the policy landscape of the United States is changing so rapidly right now because Congress passed the bipartisan infrastructure deal, which wasn't, I wouldn't argue it's a major climate policy, but it did have a lot of investments in grid transmission, bulk scale transmission in there, and some new authority for DOE to speed up transmission approvals. But the big policy on the table right now is the budget reconciliation package that emerged from the House just last week. And that's considering um, many hundreds of billions of dollars in investments in clean energy technology. So kind of the two main policies are extension of the clean energy tax credits for wind, solar, storage, and other clean energy technologies. And then the other one is the what's called the Clean Energy or Clean Electricity Performance Program. And that is essentially a payment structure. Remember, this is budget reconciliation, so it has to be policy in terms of financial payments from the federal government. And it's a structure where utilities that hit clean energy targets or clean electricity targets receive large payments that then flow back to customers. So it reduces the cost, but still incents the change and acceleration of clean energy deployment. And then there are penalties for utilities that fail to meet those thresholds. So those are kind of the big two drivers. I think combined, they're likely to get us pretty close, or if not all the way to where we need to be on pace for a safe climate, or relatively safe, or avoid the worst impacts. How about of climate change?
Yeah, absolutely. That's good. That actually sounds quite optimistic. Maybe even unexpectedly so, since we are so used to hearing such pessimism.
Yeah, it's I think we're in a place where the climate emergency is a top policy priority for the Biden administration, the Democratic Party, and there's quite a short or precious window that a lot of those policymakers, in the advocacy community, are really focused on taking advantage of that. So yeah, it's really meaningful action, and I think it's going to move the needle.
That's excellent to hear. And so one of the biggest things sort of, I guess, standing in the way, you could say, of, cleaner power and all of this is phasing out fossil fuels and the need
Yeah.
to get rid of them. And so how quickly should we be doing this, phasing out fossil fuels, excuse me, fossil fuels in the power grid? And what methods should we use? And what would you say are the biggest challenges of truly getting rid of fossil fuels for good?
Yeah. In terms of um, well, let me start with the challenges first.
Mhm.
So especially in the grid, you know, there I would say let's call them two major challenges. Well, let's call them three major challenges for phasing out fossil fuels. The first one is around the affected communities. So while the job creation on net from transitioning to a clean electricity system will be overwhelmingly positive, the negative impacts will be felt in sort of in outsized ways on local communities that rely on employment and tax revenues from, say, coal-fired power plants and coal mines, or oil and gas extraction. And you know the policy around economic transition has to also focus on helping those communities transition, and whether that's citing clean electricity projects in those same communities, providing job training, providing some supplemental transition funding and tax income so that social services in those communities don't completely collapse, is going to be crucial, right, for having a just and equitable transition. So and while like the benefits are diffused, when the negative impacts are concentrated, that's a politically different or difficult situation, for politicians that are trying to manage their priorities as well. The second bucket is sort of the new paradigm for system operations and reliability. So system operators and utilities, those entities they know how to operate the system with dispatchable spinning generators. And I don't want to get too down like the wonky technical road, but essentially, operating the system that's from one that's dependent on fuel availability to one that's dependent on weather is a major shift. And the machines are different, the electronics are different as well. And so there's going to need to be major reforms, and a new accounting for what does a system look like that's reliable, and how do we know it's reliable? Because we haven't operated a system with that high of a share of weather dependent resources. So that's another challenge. And then the last challenge is just the financial inertia, right? A lot of these fossil assets have useful lives. That's like accounting language, but basically we're planning on using, when we built them in, say, like the mid 2000s, there was a lot of gas built. And in the 90s and early 2000s, quite a bit of coal was still constructed and built. And those were planned to be around, to 2030, 2040, sometimes 2050. Same goes with pipelines. So that's a lot of debt and expected earnings on those plants. And if they're no longer useful and they're no longer earning, that means, someone in the finance industry that underwrote those loans or shareholders for those companies, value is getting wiped out in the financial system, right? And so that needs to be addressed as well. But those are some of the biggest challenges. Now, how quickly should we be phasing those fossil fuels out? I don't think anyone knows the answer exactly. Our study showed that we likely don't need any new, gas or fossil generation to maintain a reliable grid. We have 500 gigawatts of existing gas and 200 more gigawatts of existing coal. Peak load is in the United States is about 750 gigawatts. So, we have what we need. We need to focus on getting off of coal first. It's the most highly emitting and the least flexible, so it's not really compatible with renewables either, and it's also more expensive than gas. And so I think step one is phasing out coal as soon as possible. And then, we'll rely on gas as a source of power and flexibility rather than energy as we add more renewables onto the system. So, it's not just how many, plants do we have, it's how often are they running, because ultimately the climate cares more about how much you're burning fossil fuels. So yeah.
Wow, very interesting. And you bring up some points that really illustrate, I think, how challenging it is to just shift away from fossil fuels and how it's not necessarily as easy as it's often said. Myself, as a former resident of West Virginia, I've seen kind of like firsthand, some of those issues how they've been brought up and not always properly addressed. And so,
Yeah.
when it comes to achieving these decarbonization goals, how much can utility companies play a role in all of this to,
Yeah.
reduce greenhouse gas emissions, and or do a lot of this has to kind of come from the federal government up above?
Well, I think utilities, they can do it all on their own. A lot of utilities have adopted voluntary net zero goals, mostly on a timeline that's too far in the future to make a difference today. But a lot of some of the largest, utilities like Duke Energy and Southern Company, XL, these are big companies that are pledging to be net zero by mid-century. Um, but support from federal and state policymakers helps in many ways. We can help utilities reduce the cost of the transition through policies like the Clean Electricity Payment Program, like tax credits, so that when they go to regulators and say, this is not just the right thing to do, it's actually the cheapest thing to do. That's a really important complementary role that we can have. And since we don't have any way of valuing, carbon reductions like a carbon tax or anything like that, um, you know, there's no cost savings, and no way for regulators to like value clean energy. Like like it actually matters out in the real world. So that's really important. We can also the regulators at the PUC, they have to be on board, right, with the regulated monopolies and what they're trying to do. And so collaboration and support from regulators for faster decarbonization is really important. And also they have a role to play in like how accounting for those uneconomic or early retired fossil assets works as well. There's a policy called securitization, which basically means like refinancing an uneconomic coal plant with a low interest publicly backed loan, which can really reduce the cost associated with those plants. So that's one example like of direct support from state regulators or legislators that utilities need, I think, to accelerate the transition. Um, and there's also just wind and solar in particular really benefit from a larger, more geographically diverse grid. So one of the best ways to integrate those resources is to build long interregional transmission networks and then operate and plan the system over a bigger area. When the wind's blowing, not blowing in Kansas, it might be blowing in Georgia or Illinois. So it's sort of the further and more interconnected you are, the lower the variability of renewables in general, and like the less you need these other backup resources like gas. So the Southeast and the West, they don't have regional markets. They're all just these balkanized state by state or even utility by utility systems. So, we need help and support from the Federal Energy Regulatory Commission, Congress, and these state governments to figure that out and make those regional markets work for consumers. Um, so yeah, there's a lot of sort of many actors that need to be heading in the same direction. And really fundamentally, that's why federal action is so important. We need to get everyone pointed in the same direction to put pressure on institutions that like need to reform and need to accelerate the transition. But we can certainly do it, and utilities can do it.
Yeah, absolutely. And it's really fascinating that how, once the infrastructure is really planned out and scaled, that we're less constrained by the geographic sort of limitations that some of the renewables have and are often criticized for.
Hmm.
And so with that possibility in mind and those, restrictions being less of a problem, like you said, with proper infrastructure and planning, what renewable technologies do you see making up the bulk of the grid, by
Yep.
2035?
Well, the further out into the future you look, the less confident you should be about what the most economic resources are going to be, I would say. Um, but at the same time, these are really long-lived assets. And so I think, I try to focus on, what's going to happen, what should happen in the next 10 years, and what can we do with existing technologies. And so, because solar and wind are really the cheapest sources of electrical energy on the planet and getting cheaper as the technology continues to improve. I think those are going to be the dominant new technologies on the grid. And with increased federal support, um, their use is only going to increase and I think, accelerate deployment. Batteries are also really important technology. And while the scale in the US and globally isn't quite, it's quite a few years behind the rates of deployment of solar and wind, that those costs of lithium ion batteries have really come down. And we see like more than half of the projects in the interconnection queue, this is kind of the projects that are asking to get on the grid, are hybrid projects. So it's solar and batteries or wind and batteries. And that helps, grid operators not just be relying on when the wind blows and when the sun is shining, but there's a lot of flexibility in there and being able to shape the output of those power plants. And so, batteries are gonna be a really important, grid technology as well as, supporting electrification of vehicles and resilience of communities and homes. So um, the other one that I will just mention is electrified end uses, like especially electric vehicles and smart devices. So, as the output of the grid becomes more variable, um, or output of the generators, the value of flexible or managed vehicle charging, and pre-cooling buildings, of delaying use, or throttling an electric water heater down to a lower output. Those things in aggregate are going to have higher and higher value. And as we continue to have a smarter grid, and technology enters the home more and more, I think we're going to see the role of those devices really increase as well.
Very interesting. And we just got an audience question here that I want to address because it brings up a really interesting point about this transition to renewables, which is, issues they may have that we may not really foresee ahead of time. So this question is asking, what is the estimated impact of the waste that would be created by renewable energy sources after their functional life is over?
Yeah, yeah, that's a really important question to ask, I think, about all resources. I don't have like a good quantitative answer for that question. Um, my impression is that a lot of the components could be recycled, and then some will be wasted. Um, I think no technology is perfect in creating sort of zero externalities or zero waste, and wind and solar are no exception to that. I think batteries, um, my impression is almost all of the components of batteries can be recycled and reused. Although the value chain and who pays for that is something that needs to be worked out and ultimately regulated. I get frustrated by the lack of sustainability, like in that businesses are held to, and that we don't have to sort of pay for disposal upfront. Um, I think this is going to be a major problem in the coal industry, for example. Like, who's going to pick up the cost of cleaning up coal ash, um, that's been collecting and sitting by coal plants for 30 years? Will the utilities be able to afford uh, that cleanup that they're required to do? Will they go bankrupt? Same with mining. So yeah, there's a lot of issues to be addressed, and solar and wind are certainly no exception to that. But I think my sense is that it's probably from at least a public health perspective, um, a step up, but we have to do it properly.
Hmm. And while we're on that subject of, remaining challenges, do we need, in your opinion, any additional technology breakthroughs like, say, longer duration battery storage or, cheaper carbon capturing to reach these targets that have been outlined?
Mm.
Or is a lot of this really possible with technology that kind of already exists?
It kind of depends on what target you're talking about,
Hmm.
um, and how much you want to pay. So like, um, from like a technical standpoint, right? Renewable, like 100% clean, may be possible with existing technologies. But as you get more and more renewables as a share of the total, like solar and wind in particular, you have to overbuild, to have the power output fit the window that you need. So like getting from, we're at 40% clean now to 80 to 90% clean with existing technology. I think that's where like modelers and uh, grid experts are converging, that there's a pathway to do that. But if we're talking about getting to 100% carbon free, which is President Biden's goal, and and I think a really important aspirational goal that we should focus on. Yeah, I think there is some new technology that's going to be needed. There's a um, The grid needs some kind of dispatchable resource that provides electricity when we have kind of not enough energy for maybe 1 to 2 weeks out of the year coming from wind and solar. So like those short duration batteries, the hydro, the nuclear, existing nuclear aren't enough, right? So we have to have something that can come and fill in those gaps. Um, So yeah, I mean, there are a lot of candidates for things that are promising that can provide that without emitting greenhouse gases, but none has achieved scale. Um, so I think continued federal and state investment in research, development, and deployment of these technologies is really crucial so that they're kind of ready in the late in the like early 2030s to start to replace a lot of the existing gas.
Very interesting. And one thing that you mentioned that I want to at least briefly kind of touch on, because I do think it's interesting because of its controversy, is what role nuclear energy may play in decarbonization,
Yeah,
because it is technically not renewable in a sense, right?
right.
Um,
No, it's not.
Yet much cleaner. So I'm
Yeah,
curious about its role in the future.
yeah. I mean, to meet some of these ambitious goals, um, I think there are good arguments for why nuclear is not desirable. I mean, we see what Germany decided to do, right? They prioritized retiring nuclear over phasing out their coal fleet because they felt like after the Fukushima disaster, it just wasn't safe and they didn't support its continued use. Um, but from a climate perspective and achieving the scale that we need, we really need to keep the existing nuclear fleet around as long as it continues to operate safely in the United States. And so that is a climate imperative, I would argue, and a very low cost, relatively low cost way of not backsliding. Um, but with regard to new nuclear energy, um, you know, the plants that are being built or have recently been attempted in the United States have been inordinately expensive of sort of existing nuclear technology. The Vogtle plant in Georgia is kind of the only one that's under construction, and I think it's about triple over budget compared to the original estimates. And nuclear is just quite expensive. But I think my understanding is that small modular nuclear reactors are a really potentially promising solution, definitely worthy of continued investment from public and private sector. But we'll see. It's going to have to compete against other emerging technologies as well. So, like to say we must build more nuclear, I think is, um, you know, premature. But I think we certainly should be open to it um, as an energy source. And we're gonna need to invest in a lot of different technologies to get where we need to go.
Absolutely. And before we wrap up here, I just want to maybe briefly mention that this is probably, I imagine, this whole goal will create a ton of jobs, right? And have a positive impact on job growth. Is that what you guys have seen in your research?
Yeah. Yes, emphatically yes. Like I said before, there are going to be winners and losers. Um, we've seen, so my colleague Dan Esposito did a meta-analysis of all the major studies that looked at 80% or something around there clean electricity by 2030. And those studies found between 500,000 and a million jobs supported between now and 2030 by a policy that would push that. That's a net increase from business as usual. So that's a really big number. And it's mostly focused in the solar, wind, and battery industries, and also transmission. Um, but yeah, we have to. It would be a big increase. So there's a lot of like supporting labor policy, both to manage the jobs lost in certain sectors and to support job growth, and increasing prevailing wages in those industries too. That's going to be needed to maximize kind of the positive impacts of this vision for a clean, affordable, reliable grid.
Well, excellent. Super exciting. Michael O'Boyle, thank you so much for joining us today. This was an excellent conversation, super fascinating. And thank you all for listening in and contributing your questions when you had them. Be sure to share your feedback with us over in our survey, which is in the chat. And we hope to see you all at the next event. Thanks again, Mike. Take care.
Thanks, Diego. It was a pleasure.